So in this sum you can see a hook in here that shows that this 2 ohms and these 2 ohms are in series, because the hook it's 4 ohms, and let's do this 2 ohms and this 2 ohms are in series, so that's another 4, and those two are in parallel. So then the equivalent of this is 4 and 4 is another 2 ohms. The above this one and this one are all in parallel. 1 by 2 plus 1 by 2 plus 1 by 2 is equal to 3 by 2, and you have to reciprocate it, and 2 by 3 ohms becomes your equivalent, can you see 2 by 3 ohms answer. Next sum, there is no hook here in the middle, so then that shows that these two are parallel. 4 and 4 makes it 2 ohms, 4 and 4 in parallel makes it 2 ohms, and the 2 and this 2 makes in series, and so then therefore it is another 4 ohms. That 4, the below 4 and the middle 4 are all in parallel, so it's 1 by 4 plus 1 by 4 plus 1 by 4, 3 by 4, and therefore it is 4 by 3. You have to reciprocate and you get this answer. And this means it's just parallel connection, as I told you. This is R and R and R are simply parallel and by the simple wire. So you know it's 1 by R plus 1 by R plus 1 by R, which is 3 by R, and therefore it's R by 3, and you got this answer. And let's go to next sum. Since the A and B are here, you have to start doing that from here. So this to series 6 ohms, 6 and 3 are in 6 and this 3 are in parallel. 6 into 3 by 6 plus 3 is 18 by 9, which is 2 ohms. That 2 and this 4 are in series, so it's 6 ohms, and that 6 and this 3 are in parallel. Again you will get the same formula, so 2 ohms. The 2 and 4 are in series, so 6 ohms. 2 and 4 are in, so 6 ohms, that's the equivalent, and you got it. Okay, let's go to next question. So it's here, can you see that this resistance, these are all in parallel, and eventually that's in series with this R. Okay, so it's 1 by R plus 1 by R plus 1 by R, 3 by R, which will become R by 3 plus R, which is 4R by 3. We got this answer. So in this case, if you see that this R, this R, this R, this are all parallel, so it's 1 by R plus 1 by R plus 1 by R plus 1 by R, it's 4 by R, so R by 4, and you got this answer. In this, if you see, it's like Wheatstone's bridge, because your A and B can be extended here. P by Q is equal to R by S. So the row current will flow through this 2 will be in series, which is 2R, these 2 will be in series, which is 2R, and those 2 will be in parallel, so the R is the equivalent resistance, and you got this as your answer. So let's go to next sum. They're asking you for the potential difference between A and B, then you should ignore these 2 wires, and so then you should take only this and this into consideration. Therefore these 3 are in series, so it's 30 ohms. That is in parallel with this 10, so 30 into 10 by 30 plus 10 is 40, so it's 30 by 4 or 15 by 2, and that's going to be in series with this 10 ohm and this 10 ohm, the extreme 10 ohms. And so we got this, and it's going to be series. So 15, okay, so it's 15 by 2 plus 10 plus 10, and so you have an answer, so 15 plus 20 plus 20, which is 55 by 2, which will be 27.5 ohms. So that's done. They're asking next, what is the potential, what is the equivalent resistance between A and C. They ask you A and C, you ignore this wire and this wire and make it symmetrical like this. And so therefore you see, if you do like this, these 2 are in series 20, these 2 are in series 20, 20 is in parallel, so 10, that 10 and this 10 and this 10 together will make it 30 ohms, and that's the equivalent resistance. So let's go to next question. Is this one. In this one, if you see, as soon as you see this, you know this 5 and 5 are in series, which makes it 10 ohm, and that 10, this 30 and this 15 are all in parallel. So then it's 1 by 15 plus 1 by 30 plus 1 by 10. So your LCM is 30, 15 2s are 31s are, and 3s are, it's 2 plus 1 plus 3, it's 6 by 30, which is 1 by 5, so equivalent resistance is 5 ohms till here. That's going to be in series with this R and this 10 ohms, so it's 15 plus R is the R equivalent of the circuit. And you know that I is equal to voltage by 15 plus R. I itself has been given to be 0.2 amps, total current is 0.2 amps. So then you multiply both sides with a 10. So you get 60 by 15 plus R is equal to 2, and this will become 30. R is equal to 15, R is equal to 4. What is the mistake? We got R equivalent is 15 plus R. The voltage is not 6, voltage is negative and negative is connected. So its equivalent EMF is just 4. So it's 4 by 15 plus R is equal to 0.2. So then multiply both sides. It's 40 by 15 plus R is equal to 2. This becomes 20. So 20 is equal to 15 plus R. And so then unknown resistance becomes 5 ohms, and that's the value of this resistance. Yeah, I've just changed it to small r, it can be capital R. So we got it as 5 ohms. However, this is showing 4 ohms. If you want to dispute with me, you just can tell me what could be wrong. Then they are asking me for the potential difference between A and B. I found this to be 5 ohms, okay. And I can, I know the current, I can use, I know the current also, and I want to find the potential difference between A and B, which will be the potential difference between, I want to find the potential difference between A and B. Wait a minute. Ideally, I should know the current that's flowing in the 15 ohms, 30 ohms. Ideally I need a current that's flowing inside this, and it's in the ratio. This is 15, this is 30, and that is 10. So the current will get split up as 15 and this 30 and that's 10. The resistors on the ratio. And you know the value, this is 5 ohms, is it? Okay. I'm going to tell you something very, very important now. Okay, so now you delete this, all that I've done, I will just delete it so that you can understand what I'm going to do now. This is a very difficult sum. As you can see, I want to find the potential difference between A and B. I need to know what is the current that's flowing through here. I know that the resistors are in the ratio 15 is to 30 is to 10. When the resistors are in the ratio, what happened? When the resistors are in the ratio 15 is to what's happening? $30 is to 10. You know how the current will be split up? I'm going to tell you something important. 1 by 15 is to 1 by 30 is to 1 by 10 is the ratio in which the current will get split. So I hope you understood. Which simplifies to 2 is to 1 is to 3. So this will become, actually this is 2 is to 1 is to 3. That's the ratio. So if you see, this will be actual ratios. This is 5 2s are 10, 5 3s are 15, and 6 5s are 30. This is the ratio, which is 3 is to 6 is to 2. This is the ratio of the resistances. You just 1 by 15 is to 1 by 30 is to 1 by 10 is the ratio of the currents. So then you are actually multiplying it throughout with the 30. Imagine this is getting multiplied with the 30. So you immediately get the ratios of the current. It's very, very beautiful. I hope you all watched this video. I want a confirmation from everybody that you've seen it. When you have 3 resistors, the ratios is 15 is to 30 is to 10. The currents will be 1 by 15 is to 1 by 30 is to 1 by 10. You multiply throughout with the 30, a common factor, common multiple, and you get 2 is to 1 is to 3, which is like a 2 by 6. A 2 by 6 of the total current, which is 0.2 is what is going to flow here. And this is 1 by 3, and 0.2 by 3 can be written as 2 by 30 or a 1 by 15. And that's the value of 1 by 15 amps is the current that's flowing through here. I want the potential V is equal to IR, which is 1 by 15 into 15. So it is 1 volt is the answer. And I'm getting this answer perfectly. Such a beautiful sum. So this is wrong. And that value, I'm not getting it as 4, I'm getting it as 5. That you can verify and tell me. So let's continue with the next sum. Let's go to this sum. You have a battery with an internal resistance of 2 ohms. What are they asking? A voltmeter of resistance 998 ohms is connected to a 2 volt battery with the internal resistance. Find the potential difference across the voltmeter. Okay, let me take this sum, 7 point. Find the potential difference across the voltmeter that across the terminals of the cell and percentage error in reading the voltmeter. So many things are there given here, and the moment you see that internal resistance, external resistance is 998 plus internal resistance is 2, so the equivalent resistance is 1000 ohms, adding this and this, and you know that I is equal to E by capital R plus small r, and E itself is 2 volts here, by 1000, which is 1 by 500, or we can say 2 into 10 to the power minus 3 amps. So we got that current that's flowing through the circuit, and you know the potential difference across the voltmeter is simply V is equal to IR, because you know the resistance of the voltmeter, which is 998, and the current through the voltmeter is this. So you just multiply this and you get the voltage or the potential difference across the voltmeter. Now if they ask you for the percentage error of the reading in the voltmeter, you must do the percentage reading in the voltmeter, it's E minus V by E into 100. The error, you know, when you buy a battery from the shop, it will be E. What you are measuring is this, and the percentage error is a change in the voltage by original voltage into 100. So that's superb question. So you just substitute the respective values. So 2 minus 1.996 by 2 into 100 will make it 0.2%. I hope you all understood. It's a very, very interesting question. So let's go to next question. 79th question in Aurora, where a cell is connected across an external resistor, 12 ohms, supplies a 0.25 amps current. When the external resistance is increased to 4 ohms, increased by 4 ohms, it's increased by 4 ohms, is it? So which means it's going to become 16 ohms. Okay, so initially you know that you have I is equal to E by capital R plus small r, where I is 0.25 is the current has been given, and E itself you don't know, but you know it's 12 plus R. Next you're going to increase it by another 4, so at that time they notice the current to be 0.2 amps, so E is equal to E by 16 plus R. So divide this equation 1 and equation 2, and so you will get what is it, equation 1 by 2, you get 0.25 by 0.2 is equal to E and E get cancelled, this goes up 16 plus R by 12 plus R, and this can be multiplied by 100, which will make it 25. This can be multiplied by 100, which 25 by, no, I'm multiplying by 100, so this will become that will become 25, and this will become 20. So it's 5 by 4 is equal to 16 plus R by 12 plus R, and cross multiply you get R is equal to 4 ohms, and once you get R to be 4 ohms, they are asking what is your EMF. Internal resistance we found out of the battery, and then they are asking EMF of the battery. So you can substitute this in one of the equations, you know, small r, you can take this and substitute it here, and you can find what will be your E value, and when you're doing so you get E to be 4 volts. You can substitute and see. That's that question. So let's go to next, very, very interesting question. So let's go to next question, which is the 80th question, and here is the battery of internal resistance of an external resistor. Okay, so then you know that there is also 1 ohm resistance which is to the ammeter, so you adding all that, it's 55 plus 1 plus an R ohm, so it's 56 plus R ohm is the equivalent resistance, and you have what is the current that's flowing through, the current is 50 milliamps, they've given it, so then it's 50 into 10 to the power minus 3, can you see it's been given, and so then the EMF of the battery is also 3 volts, and so you know the what are they asking? They're asking you for the internal resistance small r, and you know I is equal to E by capital R plus small r. I itself is given to be 50 into 10 to the power minus 3 is equal to E, which is the EMF of the battery, which is 3 by capital R plus small r, which is 56 plus R. So when I cross multiply this, I should get the answer. So try this sum, and that's what they've taken this to the other side and they brought this down, and then they're writing 56 plus R is equal to 60, so R is equal to 60 minus 56, so 4 ohms is the answer. So it's very interesting. So let's go to 83rd example. So this, if you see, they've given a graph between I and B which is parabolic here, and and then they given but you know that IV graph. Okay, I've taught you this, an IV graph or a VA graph where we do this, and this is minus R, and I taught you this by the formula by V is equal to E minus IR. You know that this is already existing, but this is of course IV graph, not a VA graph. So you might end up getting an 1 by minus 1 by R, a reciprocal of the resistance, what you might get in this sum. So then how did they plot this graph? Is by putting V is equal to E minus IR and substituting every value of the current. They're taking current to be 0, then current to be 1, current to be 2, current to be 3. Thus they are getting these values, and then you can put when I is 0, which is your y axis, your current x value is voltage value is 1.5. When I, which is 1 amp, your voltage value is 1 comma 1. Like that they plotted this graph, and then they are trying to locate a point where this parabola meets this straight line that you have drawn. It happens to be projected along x-axis. It's 1 amp and 1 volt. Therefore, the question is the current drawn from the cell is 1 amp and the terminal potential difference of the cell is 1 volt. This is in one way. When they give you this graph, you can find what is the terminal potential difference and the current drawn in the circuit. Okay, I hope you're clear. So that's so that's there in Aurora. So let's go to next question. The next question is this. When this is a proper VA graph, and you know the slope itself is minus R. What is the slope? Is opposite by adjacent. The opposite is here and the adjacent is here. And when you substitute that, you get the internal resistance. Now, what are they asking you to determine? Potential difference across the terminals of cell. Okay, a graph is drawn. Determine EMF of the cell, is it? Okay, so you know when I is equal to 0 is when V will become equal to E. So this point, the y-intercept is where what is the value for your EMF. Okay, so what is it? It's from the graph you can infer that it's 1.4. So E itself is 1.4 volts. And then the next question is the maximum current that can be obtained by the cell. The maximum current I max that can be obtained from the cell is this 0.28 from the graph. I max is equal to 0.28. Just read from the graph. The internal resistance, as you know, is opposite by adjacent, which is 1.4 by 0.28, which is 5 ohms, and thus you get the internal resistance, which is the equivalent internal resistance. Okay, but in this sum they have not specified that this consists of 3 cells, because this goes up to 3.5. So it's not possible to have this is just a normal sum. But if they say that this is made up of 3 cells, then the equivalent resistance should have to be divided by 3. But however, we don't have to do that. They have not specified it. So let's go to next question. So this question, if you see that there are many batteries and the internal resistance, and there is also an external resistance. You can add all the EMFs, because they are all E1 plus E2 plus E3, which will account to 5.3 volts. You can add all the resistances, which is 5.75, because they are all in series only. I is equal to E by all the resistances, so it's 5.3 by 5.75, which is 0.92 amps. So that's an easy straightforward sum. Let's go to next sum. The next sum is in here, where you have an R and R which are connected in parallel. The equivalent resistance there is R by 2. And here you see that this is 1.5 and this is 1.5. So then what can I say? The equivalent resistance, you can club this together. They seem to have clubbed these two together, where they are converting it into R by 2, and they are keeping a 1.5 volts and the resistor here, and together on the top, if you see a 20 and a 20 makes it 10 ohms, and at the bottom you have a voltage which is supplied by the battery. Okay, so then what are they doing is I is equal to E by capital R plus small r, and you know 10 ohms and an R by 2 is the equivalent resistance. So it's 10 plus R by 2, and the EMF they are taking still as I, and I is equal to, they are doing it like this. and so then you get 3 by 20 plus R. And you also know I is equal to V by 10 ohms, V by R, which is 1.2 by 10, which is 3 by 25. You can equate this I with this I. How did you get this? I is equal to V by R. I is equal to V by R, which is V is 1.2 by resistance is just 10 ohms. I think that we can take this 10 ohms and this battery here, which is positive to negative, and apply a loop rule and see. So you get when you travel from anti-clockwise, you go, it's minus 1.2. And when you go here, do you know the value of the current that's flowing into that? Or you don't know the value, so you can't use loop rule. Then how did he get this value? I is generally is equal to V by R. V is just 10. Because in this, the potential is still V because it's parallel. And so you find the current here, I is equal to V by R, which is V by 10. So you know the current through here is 3 by 10. Okay, and the current through here is 3 by, and what is this current here is I is equal to, which is the total current, obviously. And how is he equating these two is the question. Okay, I didn't quite get this sum. Let me think about it. Okay, kids, I'll just tell you one thing. Okay, I'll give you more clarity on this sum. Sorry, I could have done it well. I was in some hurry to finish it. Can you see this? It's E1 R2 plus E2 R1 by R1 plus R2, 1.5 into R plus 1.5 into this R by an R plus R is 2R. So you get 3R by 2, 3R by 2R, R and R. So you know this is just the equivalent EMF is just 1.5. Okay, the equivalent EMF is just 1.5 and the resistance is obviously R by 2. This gets transcended into something like this beautifully, which is just 1.5 volts. So that is sorted. Okay, that was sorted. That part is clear. So now let's go to the top part is 20 and 20, which makes it only a 10 ohms which is connected here. Okay, and then you have an external voltage which is coming here, an external voltage which is coming here, which is like this, and you have a 1.2 volts. I understood till here. So now you know the equivalent resistance is 10 plus R by 2, and I through the circuit, I is equal to E by capital R plus small r. And in this circuit, in this circuit, I is equal to E, you take it as 1.5 plus capital R is 10 ohms plus R by 2 is the taking just into consideration this circuit. But when you consider that will be the current that will flow through this end and this end, which can also be judged using this 1.2 volts because they are parallel. This whole thing receives only a 1.2 volt potential. So then I is equal to V by R, which is 1.2 by 10, and you can therefore equate this with this and then find answer. Okay, I hope you're clear. Such a superb sum. Superb is the word. Okay, I'm sorry I messed up when I was explaining before. So let's go to next question. So here is the sum, which is the 89th question. 89th question, you have the 4 resistors which are all in parallel, 1 by R plus 1 by R plus 1 by R plus 1 by R. So it's 4 by R, so then it will become R by 4. And so then you got R by 4 to be your equivalent internal resistance. And apart from that, you have this 15 and 15 which are parallel, which will be 7.5. So then the total resistance is 7.5 plus R by 4 is the equivalent resistance of the entire circuit. And what else I can say about this? And they have given EMF to be 2 volts. They have given in this question, as shown in the figure, they have given EMF to be 2 volts. Okay, and they have given the voltage terminal potential difference to be 1.6 volts. And therefore the question is to find the internal resistance, the total internal resistance of all the 4 cells. Small r is equal to capital R into E by V minus 1, where it's R equivalent, and capital R is 7.5, the equivalent external resistance, E by V minus 1. They have given E and V, which is 2 by 1.6 minus 1. Thus you get your R equivalent, which is 15 by 8. Once you get R equivalent, you know that the R by 4 is the actual equivalent resistance, and that can be equated to this value. So R by 4 is the equivalent R by 4 is the equivalent resistance. R by 4 is equivalent resistance, which actually is also equal to 15 by 8 now. So 7.5 ohms is the resistance of each cell. Such a brilliant sum is this question. You just learn this. So good, so good. So let's go to next question is here, which is you have two batteries of 4 volt and 8 volt. They are connected with opposite polarity, so the equivalent EMF is just 8 minus 4, which is 4 volt. The resistances, internal resistance, those two are only in series, which is also in series with this 4.5. So add all the ohms here. It's 1.5 plus 4.5 is 6 ohms. That 6 ohm, this 3 and this 6. So then you get this, and I'm thinking they're all in parallel. What is that what they're asking me to do? So I got this, all this equivalent to be 6 ohms, and that seems to be like my main house. Okay, and then the equivalent resistance of these two is 3 into 6 by 3 plus 6, which is 9. So it's 18 by 9, which is 2. And you already have a 6, and this 2 will become 8 ohms. And so then the total voltage is 4 volt by 8 I is equal to V by R. So 1 by 2 amps is the current that's flowing through. Say 0.5 amps is the current that will flow through here to the main house. So it's 0.5 amps or 1 by 2 amps flow through here, and the resistors are here in the ratio 1 is to 2. The current will obviously be in the ratio 2 is to 1. A 2 is to 1 is a 2 by 3 of the total current, which is 0.5, and a 1 by 3 of the total current, which is 0.5, which is 5 2s are 10, 1 by 3, and this will be 0.5 by 3. So those are the respective values of the current, 1 by 3 and a 0.5 by 3. Can I write it as 5 by 30, and can I write it as 1 by 6 amps? So thus you get the individual values of the current in the circuit, and calculate the currents in each resistor. Done. By default are done. So easy. So let's go to next question. Is this question where you have two batteries which are have opposite polarity, which is E1 minus E2. They have given the voltages. So net voltage itself is E1 minus E2 is 2 volts. Then the resistance are all to be added, and you know that it's 5 ohms plus 1 ohms plus 2 ohms is 8 ohms is the given internal resistance plus the external resistor that's given here. So once you do that, the current is equal to E by all the equivalent resistances. So which is 2 volt by 8 ohms, which is 1 by 4 or a 0.25 amps is the current that's flowing through the circuit. Once you determine the current that's flowing through the circuit, they might ask you for a terminal potential difference of every cell. So current inside the cell E2 flows from, so look at this, in this the current is flowing from negative to positive. So then they want the terminal potential difference of this battery. V is equal to E minus, I wish you know which is bigger voltage. This is 2 volts and therefore this is 4 volts, which shows that a 2 volt battery is getting charged by the 4 volt battery. When it is getting charged, then the formula is V is equal to E plus IR. And when it's discharging the current, where this is the higher volt battery which is discharging, so V is equal to E minus IR. This variation you should understand. So then you put the EMF of the battery is 4. The value of the current is 0.25. The internal resistance of the battery, which the second cell is given to be 2. So it's 4 minus 0.50. So can I say 3.5 volt is the terminal potential difference of this battery. I have to suppose when it's discharging, I'm supposed to use V is equal to E minus IR. The lower battery will always get charged, so V is equal to E plus IR. So EMF of the battery first cell is 2 volt plus the current is 0.25. The internal resistance of the first one is 1. So 2 plus 0.25 is 2.25. So 2.25 volts is the terminal potential. It's very, very important sum. So let's go to next question. In this question, if you see, there are where is this question? You have 12 cells of each of voltage 1.5 volts and internal resistance 0.5 ohms are arranged in rows, each containing n cells. So you know that when it contains n cells and 12 cells of 1.5, each one is 1.5 and 12 cells are connected in series, calculate the value of n and m for which this combination would send maximum current through an external resistor 1.5 ohms. There is an external resistance of 1.5 to receive a maximum current through it. You know the equivalent R equivalent should be equal to NR by M. I taught you this in the theory itself. The R equivalent should be equal to the external resistor should be equal to NR by M. The external resistance is 1.5 should be equal to NR by M, where N stands for this numbers and M stands for this numbers, correct? So an internal resistance of every cell is given to be 0.5 and you know that there are totally 12 cells which are arranged in M into N. So M into N is equal to 12. So M can be written as 12 by N. So you replace this as 12 by N. This becomes N square and hence you can calculate 1.5 is equal to N square into 0.5 by 12 and this is 0.5 into 3, N square is equal to 36 and N is equal to 6 and put it here, you get M is equal to 2. So thus you can, if you know that it is 12 batteries which are arranged in N like this and M like this, then M into N is equal to 12. It's such a beautiful sum. Okay, so let's go to this one. The last sum for the day, you can see from this is a VI graph and you know that internal R equivalent is minus R, so opposite by adjacent, which is 5.6 by 2, which is 3 2s are 4, 2 2s are 4, 8, 2.8 ohms. But they are they specifying for each cell the internal resistance for each cell, which means they have made it into 1, 2, 3, 4 cells. Have they given in the question that consists of 4 cells? If they are not, you should understand from here there are 4 cells divided by 4, so then the value is 0.74, so 0.7 ohms is the internal resistance of each cell. Then what is the EMF? When the current is 0, the EMF will be 5.6. 5.6 and divided by how many cells are there? 1, 2, 3, 4. Divided by 4. 5.6 divided by 4 is 5. 4 ones are 4. 4 4s are 16. This is the term EMF of each cell. They ask again for each cell, you should be very careful. Then for what current from the cell does the maximum power dissipation occur? Maximum power dissipation will occur for maximum current. What is this? Where is the sum? So when the current is maximum, so then I think it's just a question of saying 2 amps, but I want to check my answer. I don't know where this sum is in Aurora. I'm trying to figure out where it could be so that I'm not going wrong with this sum. Just hold on. I located some example 133 in Aurora and for I maximum, okay, so I have to do this I maximum stuff because you know that the internal resistance for getting the word maximum power means maximum current also is involved. For maximum current, you know, equivalent internal resistance should be equal to the external resistor. Total EMF you have to calculate. Do you know the total EMF? It's how many batteries are there? So can I take it as 5.6? No, for one battery it's 1.4 is the total EMF. So 1.4 into 4 is the total EMF divided by, which is nothing but 5.6 only, no? Divided by the total resistance. The total resistance in the circuit is one resistor, internal resistance is 0.7. How many, don't you think you have, external resistance should be equal to equivalent internal resistance. So external resistance should be equal to equivalent internal resistance. The equivalent internal resistance is 2.8, right? That's where the problem is. I have messed up something in this sum only for this part. Okay. The output power is maximum when the external resistance is equal to internal resistance 4R. So you know the external resistance has to be equal to 4R. Considering that R are the resistances, 4R, we know it's 0.7, yeah, that's okay. So this is what is given. And so then I maximum can occur at 4E. Normally it's MNE by N into small r plus M into capital R, something like that. But here there is only series arrangement. So it's just 4 series arrangement is 4E. And the equivalent resistance is capital R plus small r. Capital R is also 4R, small r is also 4R. So 4E by 8R. So it's 4 by 2, E by 2R. And E itself is for one battery is 1.4 and 2 into 0.7, which shows that it's 1 amp. And that's the maximum current. And to calculate the power, you can use I square R, capital R. Okay, so then that's about it. I found it very, very hard, the last sum.